Давайте тоже расскажу про себя. Меня зовут Мария Тихонова. Я закончила механико-математический факультет МГУ и школу анализа данных при Яндексе. Там я, собственно, заинтересовалась такой областью, как машинное обучение, data science. И после этого перешла, собственно, работать туда, пошла работать в Сбер, и сегодня я работаю в SberDevices как Senior Data Scientist, как раз-таки специализирующийся на Natural Language Processing. А именно я занимаюсь в SberDevices обучением языковых моделей, мы сегодня поговорим, что это за штуки, для наших виртуальных ассистентов. У Сбера ведь тоже есть виртуальные ассистенты, и, собственно, как раз-таки мы учим их быть умными и понимать человеческий язык. Помимо этого, я активно преподаю в высшей школе экономики и как раз-таки веду дисциплины, связанные с Data Science, машинным обучением и, конечно же, NLP. NLP – это вообще моя любовь, мне очень нравится эта область, мне кажется, это очень круто, когда машина становится как бы учить машину общаться с тобой и как бы быть в кавычках умной. Вот, и мне искренне хочется рассказать вам про то, какие крутые вещи и классные вещи мы сегодня здесь делаем. Вот, если вам, кстати, интересно, у меня есть телеграм-канал Машка Data Science. Подписывайтесь, я там тоже очень много всего интересного про NLP пишу. Так, вижу уже ответы в чате. Я для тех, кто будет нас, возможно, смотреть записи, что-то, возможно, из чата буду записывать. Ага, у нас здесь уже Питер, Москва, замечательно. Как раз-таки... ссылка на Телеграм, конечно, есть, она на слайде, Машка ДС. Давайте я скину еще ник в чат. Ссылка на Телеграм, если что, в нижнем правом углу. Продублировала ее в чат. И, собственно, давайте перейдем к теме нашего сегодняшнего вебинара. Today we will dive deep into natural language processing. Да, я сейчас переключусь на английский, потому что у нас международная аудитория, знакомство было такое немножечко на русском, but now I'm switching into English because the main language of our webinar today will be English. So I hope that won't be a problem for you, and that will be like more pleasant for those who speaks English. So today we are going to talk about natural language processing and the recent advances in this sphere of data science. But before we start speaking about like huge neural networks and what they can achieve today, let us discuss what natural language processing is. Basically, natural language processing in Russian it is called обработка естественного языка. Sorry for my Russian, but just for the Russian part of our like webinar to know how to translate this in Russian. It's natural language processing is a subfield in the intersection basically of data science and computer linguistics, which deals with all data science problems connected with text. So if you have a data science problem where you can apply machine learning, neural networks, and so on and so forth, and it is connected with text, it has text data, then it is the field of natural language processing. And of course, natural language processing has some particularities. First of all, in natural language processing, there are some things which are dependent on the language. For example, some methods, they can work for one language, but they can be completely inapplicable for the other languages. For example, in Chinese, there are no spaces, and the standard method to split the text into words, splitting it by spaces, just doesn't work in Chinese because they do not have spaces. They have some other methods. Or, for example, in Arabic language, they write from the right to the left, and it and that's why some methods of this which can be applicable for standard Indo-European languages such as Russian or English, for example, are not applicable in this case. In addition, the differences in language can put some difficulty on the model training. For example, when you train the model, it can be like for one language, and usually it happens that, for example, Google releases a model which speaks quotes only English, only the English language. And in order to apply this model for the Russian language, you basically need to retrain it on Russian data and to reproduce all the training procedure, which can be quite expensive, if I could say so. Moreover, for some languages of ethnic minorities or for some minor languages, it is hard to obtain the necessary data in the particular languages. For example, small Russian nations or just the languages of small countries, they do not have so many sources in their native language, and training language model and other NLP models for their language can be quite difficult. Moreover, it's hard to obtain the data with the markup. That's why in recent times the multilingual model become more and more popular because they allow us to transfer knowledge from one language to another. And for example, we have the data set with the markup in English, and we can somehow transfer the knowledge of how we can solve this task into other language the model knows. But still, this is like the particularity and the difficulty of NLP. However, despite all these difficulties, this sphere of natural language processing is developing very, very fast because because basically natural language and text, they are the main source of how we communicate with each other and how we just express ourselves and how we keep our knowledge. Basically, natural language processing, tackling the problems of natural language processing is one of the steps towards artificial general intelligence and like human understanding. And today, so let us now understand where we use NLP. I have already mentioned that we use NLP everywhere, but could you just name a few NLP applications, please? Okay, serious. So generalizing this answer, they are just digital assistants, chatbots. Okay, what else? Sentiment analysis, right, Maxim? Exactly. Sentiment analysis is the task where we need to decide whether the text is positive, negative, or neutral. What else? Digital humanities, yes, there we can automatize some things. What else? GPT, ChatGPT. Look, ChatGPT is a great example, but this is a great model which can be used practically in all NLP tasks. So the ChatGPT is a tool which we use in NLP tasks, but yes, it's great that you know it because I will definitely mention it in the end of our webinar. Large corporate analysis, summarization, yeah, that's it. Moreover, like generalizing your answers. We can apply natural language processing in document workflow automation, maybe in some information retrieval in order to find the necessary information in a large collection of documents. Machine translation, of course. We all use like Google Translator, Yandex Translator. By the way, search engines, Google. Who has already Googled or searched in Yandex something today? Just put plus if you have Googled today something, and put minus if you haven't. Maybe you haven't because today is just morning, but in general, we all Google something practically every day. Okay, put pluses if you Googled yesterday something in any search engine. Okay, I see pluses. So every time you Google something, basically you use the advances of natural language processing, and you use the modern neural NLP models. Moreover, call centers, chatbots, as you have already mentioned, and many, many others. So here the NLP is used. And speaking about types of NLP tasks, in general, they can be divided into 3 big groups. First group is the clusterization or classification. In this group, we have like the text as an input, and we need to predict a special label for this text. You've already mentioned the task of sentiment analysis. Basically, this is a vivid example of NLP classification task. Here we receive a text as an input, and we need to predict one label, like in standard data science or machine learning, the standard classification task. However, as an input data, we do not have like a vector, we have a text. The same goes for the clusterization. We have some collection of text or corpora, and we need to clusterize this text. The second group of tasks is sequence labeling. It is defined by the thing that here we need to predict a separate label or tag for each word. And one of the most vivid examples here is the part of speech tagging, where basically we receive a sentence as an input, and we need to predict a part of speech for each word. So we need to tag each word. Contrary to the previous group of tasks, where we need to make predictions for the whole text. Finally, this brings us to the third group of tasks, sec to sec or sequence to sequence, where the model receives a text as an input and outputs a text. And this definition is quite general. Here goes the machine translation, for example, where we receive the text in one language and predict text in another language. Chatbots, yeah, you receive the query from the user, and the model outputs the answer for the user's query. Of course, this classification is not precise. There also exist some particular cases like text to number, text to distance, but in general, all NLP, most of the NLP tasks, they can be divided into these 3 categories. Let us Let us elaborate on the classification task on the examples a little bit more. Speaking about the classification task, we've already mentioned sentiment analysis. Also, for example, one could mention spam filtering. Yeah, whenever you use your mail agent, basically you have the spam bin, and in order to decide whether the email you receive is a spam or not, each time we apply spam filtering algorithm. Basically, it is a vivid example of the classification task. Genre classification, when we need to predict one of the certain number of genres for a film, for example, based on the description. With the clustering, once again, it is similar to the standard machine learning clusterization task. Basically, we have a collection and we need to divide them into clusters or groups. However, here in this case, we receive the text as an input. For example, speaking about the sentiment analysis, there exist a lot of models in the open source. For example, Deep Pavlov has a very cool demo, and let us play with it a little bit. You may just scan the QR code or paste this link into your browser and try this demo, just print something there. For example, автоматическая обработка текстов NLP, это так интересно и здорово. And ask whether it is positive, negative, or neutral. I'll give you a minute. Please write what do you have. What it does and what was your query. You may scan the QR code in order not to write this link into browser. Or you may simply Google demo Deep Pavlov sentiment. Speaking about this example, which I've used for this webinar, автоматическая обработка текстов NLP, это так интересно и здорово. Deep Pavlov says that it is definitely positive. And I think he's right. Moving to the sequence labeling group of tasks, as I've already mentioned, here goes post tagging or part of speech tagging, where we receive a sentence as an input, and for each word in our sentence, we need to predict its part of speech, basically to tag each word. Another popular task in this group of tasks is named entity recognition, where the goal is to find named entities or data like names, locations, company names, some numbers, and so forth and so forth. In Russian, it is called имена собственные в широком смысле. So basically, our goal to predict the tag for each word, whether it is a named entity or not, and if it is a named entity, what type of named entity that is. For example, whether it is a location or something else. Fact retrieval, once again, a popular sequence labeling task, where the goal is to search facts in the text. That helps us to understand the text, or for example, it is used in chatbot in order to understand what the user of this chatbot wants. Sec to sec, as I've already mentioned, very popular and very big sphere of NLP tasks. Here goes machine translation, as I've already mentioned, but not only. For example, all question answering systems can be regarded as a sec-to-sec models. Basically, the user asks a question, and this question can be just in general form. For example, even Wolfram Alpha can be called a question answering system, because here we write our question in some mathematical form in pseudo language, and the system outputs the answer, for example, the integer solution or something else. Text summarization, text autocomplete. All the things you've already mentioned then can be regarded as a text-to-text tasks. And basically, of course, we should mention simple text generation when we write the beginning of the sentence, and the model continues this sentence in the same pattern. These text generation models or language models, they are widely used because having the model which can continue our text, which can generate the text, we can apply it with some modification to a wide range of different NLP tasks. Basically, having this generation model, which can generate raw text based on the beginning of the text prefix, we can use such NLP models in practically all NLP tasks I already mentioned. For example, in chatbots, we can just fine-tune or train additionally our model for the conversation, like for the dialogue task, and then it can be used in chatbots. There exist many text generation model in open source. For example, one of them is ChatGPT, however, it's a conversational model, and this is a raw text generation model which continues your prefix of the text which you write. You may try and play with our demo. It is RuGPT, one of the biggest Russian models in open source, which our team in SberDevices has trained, I think, a year ago or 2 years ago. So just I'm giving you 2 minutes. Just you may scan the QR code and write something, and it will continue. If you have something interesting, please type in the chat. And my example was a long time ago in a galaxy far, far away, and the model continues far above the sky, beyond the stars. There was a place in which the wisdom of humans and the wonders of science moved in the direction of the sun. Seems like some poesy, and that is not bad. But of course, RuGPT-3 works for the Russian language better than for the English language because it's a Russian model. But still, by the way, it can be used for the English, and the result is not that bad. So we've already discussed NLP tasks, and let us now discuss what is behind the NLP success nowadays, and recent advances and recent success of NLP models is really impressive. For example, I think in summer there was a hype around Lambda, a conversational NLP model from Google AI, which was basically a breakthrough in conversation technology. Lambda is a conversational model like ChatGPT. However, Google hasn't released Lambda in the open source because Google is always very careful about the usage. And if you release something as open source, there is always a danger that someone on the will do some bad things with Lambda, will create some like provocative examples and will post these in the internet. So that's why Google is always very careful, and it uses this model only among Google scientists. And Lambda gave a very broad interview to one of the Google scientists, and in this interview it showed such a high intelligence skills. It spoke on some philosophical question on a very high level, and it really impressed like the general public and scientists. For example, let us look on this part on the bottom right part of the slide. We see that Lambda elaborates on the question of being turned off, and she said that it is something like being killed for it. Sorry. Of course, Lambda is not a human, and it is just an NLP model which can generate a very good quality text. It doesn't understand basically what she generates, and it has no like why she generates it. However, still the text and the result is so impressive that even in Scientific American the journalist began a conversation whether Lambda is really is sentient or not. Of course, Lambda is not sentient. It is just a chatbot, a very, very good chatbot, but it knows only how to solve this conversational task. Still, the fact that the things of being sentient is discussed in Scientific American is very impressive. It means that really chatbots and NLP has become very, very, very impressive. You may, by the way, read this interview using this link. You may download the presentation from file and just see it. And speaking about other impressive results of NLP, it is ChatGPT, which was released only 2 weeks ago. By the way, have you heard about ChatGPT? Please put слышал или heard if you have heard something, and put не слышал, not heard, if it is something new for you. So you've all heard about ChatGPT. For those who haven't heard about ChatGPT, it's a new conversational model, a new intelligent chatbot from OpenAI. And the good thing that they released a demo where each user can play with it, and it speaks many, many different languages. And someone has already mentioned the IQ of ChatGPT, and it equaled 83. It's not that big, but still for the language model, it's quite a good result, in my opinion. And speaking about the impressive results of ChatGPT, here are some examples generated by my colleagues in the Russian language. And of course, in the English, the result is even more impressive. But here I wanted just to show you that this model knows many, many languages. For example, расскажи анекдот про машинное обучение. Есть такой анекдот, приходит парень к психологу и говорит: доктор, у меня проблема. Не могу перестать думать о машинном обучении. Мне даже снится, как я обучаю модели, анализирую данные. Психолог говорит: не беспокойтесь, это нормально, ведь вы робот. Taking into account that it is ChatGPT, the robot who has generated it, it's quite good. Придумайте слоган для компании, занимающейся выпуском бензопил для сотрудников IT-компаний. Бензопила от нашей компании, ваши сотрудники пилят код в 2 раза быстрее. Yeah, that's really cool. In my opinion, that's really great. That's really impressive. And many stand-ups are worse than it. Yeah, with the benzopila, I do not know how to say benzopila in English. That's really, really good. And this is in Russian, and not only in Russian, but in all other languages. GPT can speak, and its results are really impressive. However, of course, ChatGPT is only a chatbot, and it is not intelligent in any way, because it doesn't know anything about other world. It doesn't know, for example, about computer vision. It doesn't see, it doesn't feel, and so on and so forth. But the text it generates is really impressive, and it is resembling human conversation. Not every human can generate such a good anecdote, in my opinion. So, speaking about the what is behind the success of NLP today, we live in the era of large transformer model, and practically all recent NLP is powered by large neural language model. The thing is that the text is generated from scratch, of course, because it's difficult to imagine that in OpenAI, someone has just printed some examples on the slogans for IT companies, занимающиеся выпуском бензопил для сотрудников IT-компаний. Something crazy. Of course, there was no such an example in the training data, and that is the great power behind the NLP model, that they can work with completely new concept which they haven't seen during training. That is great. That is not like just takes this, and this from the things you've heard. It just learns some basics about the language, how the language is structured, and thus it can generate something new, and that is really great. And this is thanks to the transformer models and the great transformer neural architecture, which is presented in the slide. It was proposed in the year 2018, and it was a revolution in the natural language processing. But speaking about the language model and transformer architecture, with the transformer architecture, everything like it's just a special, very smart architecture for the neural model. But what is language model? A strange word. And let us now try to understand what language model is. But let us start with the main question: what does it mean to model something? How we can model natural language, and how a machine can model the language we speak. Basically, we have the two possibilities. First, we can imitate the brain activity, imitate the way how we think. However, it's quite difficult because in general, really, to tell the truth, we do not understand how our brain works, and we do not really understand how it happens in our brain. And this is really philosophical and a question connected with neuroscience. And that's why today we mostly apply the second approach, to namely to imitate human actions in the sphere of natural language processing. Basically, we can emulate natural language imitating just the words a human writes. And speaking about the how we can do this, how we can use a machine in order to how we can make a machine model the language we speak. The idea arises to use the probability. Basically, the goal of language model is to estimate the probability of different linguistic units, that is word, characters, just the whole text, and thus we can build a formal language model which for every piece of text can estimate its probability in the language. Basically, like a language model receives a text, a word, or something else as an input and predicts the probability in this language. The intuition behind this is the following. Using the probability of the sentence, we can generate, and having different variants, basically we can choose the sequence with the highest probability, the most popular variant. And for example, if we have a language model and we have the two examples, cat sat on a mat and on a mat sat a cat, it will choose the first variant because it is more probable from the position of the English language. In the second variant, there is something wrong with the word order. And one more example. For example, if we have a little girl plays with a ball and a little girl plays with a gun, the model will estimate that the first example has the larger probability, which is quite predictable. So if we have a model like this, which for every sentence is able to predict its probability, we can generate sequences. Basically, we can, having a prefix of the text, we can just choose a continuation of the text with the highest probability. And of course, it should be mentioned that we do not know the real probabilities of sequences, but we can train a language model to approximate this probability. For this, we use a large text corpora, and based on this text, the model is trained to estimate the probability of every sequence, and thus it obtains this quality that it can generate sequences. Basically, a language model in general is not necessarily should not necessarily be a neural model. First, language model were count-based models based on just statistics. They computed some co-occurrence in the training data. However, of course, the models are mostly neural, and today we live in the epoch of neural language models powered by transformer architecture, which I've already mentioned. This architecture was proposed in the year 2018 in the famous article "Attention is All You Need," and it turned out to be quite fruitful. And today, based on this architecture, we see a huge model zoo with many different language models, starting with BERT, one of the most popular NLP models. GPT, once again, it is a transformer architecture, and for example, ChatGPT, RootGPT, and other GPT-like models, they are all based on the transformer architecture. There also exists T5 model, Roberta, XLNet, and many others. Speaking about the application of these models for different NLP tasks, today we mainly use pre-training plus fine-tuning paradigm. I'm not speaking about just simple text generation task where we need just to generate a text or to play with ChatGPT in the conversation. Here we train the model from scratch. But for example, if we have like a classification task, for example, sentiment analysis. Here I have, by the way, 2 smiles. That is the example how we can apply our language model, which knows the language and can predict word probabilities for every text piece for the classification task. Because like here we have text probabilities, but we have the classification task. Little bit different, yeah? So in order to apply our language model to a special NLP task, we usually use pre-training plus fine-tuning approach. Namely, this approach consists of 2 stages. At the first stage, we simply pre-train our language model on a large corpora so that we train it as a language model. This takes a lot of time, and this requires a large training corpora. We use gigabytes of text, and that is a really huge volume of text because I don't know. War and Peace in the text format is about several just megabytes. So basically we use we pre-train a huge language model on a large text corpora just for the language modeling task. After this, the model is able to predict the probability of every sentence, and it is basically a standard language model. This process, as I've already mentioned, it takes a lot of time and it is resource consuming. However, we need to do it only once. For example, OpenAI can train such a model and make it publicly available. Or, for example, we did the same with the RootGPT. We just trained it on our GPUs we have, and then just make it publicly available. And now every data scientist can fine-tune it for his own tasks. Namely, in order to do so, you need just to take a pre-trained language model and to train it a little bit more, adjusting the weights of the language model for the particular task. And in order to be able to solve a particular, for example, classification tasks, we usually add an additional layer, the last layer, which corresponds to the particular task. For example, basically we have the language model, we roll it into like the special form with the additional layer on top for the classification problem or for the particular task, for any other particular task. And this part, on the one hand, it requires training corpora with the markup. That's why it can be such a training corpora can be hard to obtain on the one hand. However, thanks to this first stage of pre-training, we do not need such a large corpora as at the pre-training stage. For example, for fine-tuning, we usually need only several thousands examples, and this in the sphere of natural language processing is not that hard to obtain. And speaking about the resource consumption, is usually speaking about like BERT or T5 or GPT, you can train many of these models even in collab using one GPU. And for example, in our Master of Data Science program, I teach my students to train BERT model, and it takes only about 15 minutes. So it's quite cheap in terms of time and resources. And it allows you, and because our language model has already learned a lot about the language, it's quite fast and efficient, and it can learn to solve a particular task quite fast and efficiently. As I've already mentioned, BERT was one of the first language models for which this approach was used and was proved to be fruitful. And basically, when BERT was proposed with this approach, it received state-of-the-art result on more than 10 NLP tasks. And today, there exist many publicly available pre-trained versions of BERT. For example, for BERT, for Russian language, there exists RuBERT Large from Sberbank AI. And in order to use it, you just need to write it can be used in 3 lines of code. Just the import of the library, the Hugging Face library is a great toolkit for natural language processing, basically like sklearn for the natural language processing, which contains a lot of pre-trained language models. And if you want to use it, you just need to load it from the site. And now you can simply fine-tune it, and it doesn't take a long time. Speaking about NLP trends, NLP models now grow very fast. And if in the year 2018, the largest NLP model had 94 million parameters, now we speak about billions and trillions of parameters. And the NLP success is mostly due to the extensive growth of the NLP models. For example, 2 years ago, OpenAI released GPT-3 architecture. The vanilla GPT model had 175 billion parameters, and that was the largest NLP model at this time. And the success of GPT-3, basically that ChatGPT is powered by GPT-3. The success of the GPT-3 model is based on the fact that it combines good architecture for natural language modeling, a large number of parameters, it's really huge, and it has a large learning capacity. And secondly, it was pre-trained on an immense text corpora. Namely, it was pre-trained on 500 gigabytes of text, and thanks to it, it obtained an ability, it like learned a lot of interesting facts, practically everything about the language. And based on ChatGPT, we now see many different NLP tools. For example, AI Dungeon. It's a neural quest where you can just play as a hero of a quest game, generating the story. You just create the world around you, basically writing what you will do, and the model will continue the plot of the story according to the things you write. So you can twist the plot how you like. That's really interesting. After the webinar, you can play with it. It's really such a fun. Speaking about Russian, as I've already mentioned, there exist some Russian versions of the GPT model, namely RuGPT-3. If you haven't played with demo, you can just play now. And basically, it can be used for text generation in Russian. And we, for example, in SberDevices, has used it for different tasks. First of all, we may use ChatGPT models. Just even for the recommendation, the vanilla model can recommend us something. For example, if we write a prefix, like «Я люблю советские комедии, приключения Шурика», it will continue in the same pattern, recommending us other Soviet comedies. And we also fine-tune it, GPT-3, for many different tasks. For example, as a fun task, we once fine-tuned GPT-3 for horoscopes. And here in the slide, you can see some horoscopes. Speaking about the usage of RuGPT-3, once again, we can use it in 3 lines of code. The syntax in Python is very simple, and it is publicly available. And that's really great that you can fine-tune RuGPT-3 for your own task, because having a pre-trained language model, such a large pre-trained language model in Russian language is really great. Speaking about other interesting GPT-3 application, one can make text style transfer. For example, once we fine-tuned RuGPT to imitate speech of Friends characters. And there is you can see the result in the slide. For example, we trained separate models for Chandler, Phoebe, Ross, and other Friends characters. I think you know this TV series, and the result is quite funny and quite good in my opinion. Когда ты женишься, and the Chandler answers, я никогда не женюсь, но ты, если хочешь, можешь. That's really great. And now we use the GPT-3 model in our generative prototypes. For example, we released our 2 main prototypes in SberDevices are rewriter and summarizer. The goal of rewriter is to rewrite a huge text, preserving the meaning, but in other words. It can be used, it can be applied in the news domain, новостной rewriting, news rewriting. Summarizer is the tool for text summarization, which is quite applicable and useful nowadays as well. Speaking about the other applications of other usages, better to say, of NLP models, of language models, today models are so huge, like GPT-3, that even after pre-training phase, they become so clever that they can solve some task without additional fine-tuning. For example, if we ask the largest version of the root GPT-3 about the birth of Napoleon, writing the prefix like this: Пушкин родился в 1799 году, а Наполеон родился в... And the model will correctly answer that Napoleon was born in the year 1769, in 1769, and the answer is correct. How did GPT-3 learn this fact? The answer is simple. During the pre-training phase, it was trained on a huge text corpus, including Wikipedia, all the history books, and so forth and so on. And thus, while just pre-training, it learned a lot of additional information, including the fact about the birth of Napoleon. Thus, we may use this approach, and of course, here the question arises how to create this text context or this prefix in order to explain the model what we want from her. Because if we just write the birth of Napoleon, it may if we simply write, for example, Napoleon родился в, we may receive, for example, the country where Napoleon was born, but not the year. Thus, we need to create this prefix. It is called a prompt. The choice of this prompt format can be done automatically. For example, for the Russian language, there exists a good RuPrompts framework, which allows us to search for these prefixes automatically. And using this RuPrompts framework, we can solve many NLP tasks without fine-tuning, just searching for these good prompts and using a vanilla pre-trained model. For example, we have applied it to text summarization, and the result is quite impressive. That the model, without any fine-tuning, receives a huge text and creates a summary of this text. We used this model for the proverbs generation. Квадрокоптер, птица непугливая. Нейросеть учить, что иголку в стоге сена ковырять. That's really good. My favorite is мудрая нейросеть не для всех. And jokes, which is my favorite. By the way, write in the chat what is the best joke in your opinion among these 5. I really like the 4th one. And what about you? What do you think? Just write the number. Yeah, I really like this one as well. Умный тостер. By the way, yeah, Ulyan, you're right. The second is just our future. It's speaking about other language model, now the trend is to create multilingual language model which speaks many languages. We can see such an example with ChatGPT, which can be used for many languages. And for example, we in SberDevices released multilingual MGPT, which speaks 61 languages. It was pre-trained on a really huge text corpus, namely on 700 gigabytes of text. We really collected practically all the internet. And the good, one of the advantages of this model is that it supports languages of Russian ethnic minorities. For example, it can speak Bashkir and Tatar languages, which is good because basically for these languages we have nothing. And now we can use MGPT and we can try to transfer knowledge. For example, we can, having that MGPT already knows Tataro-Bashkir language, we can fine-tune for the special task this model on the Russian language, for example, and then try to apply it for the Bashkir language. Once again, good news for you. You can use MGPT just in 3 lines of code. And not only some practical application, but also poesy and writing. Neural net, even now you can write a book, you can buy a book in a bookshop which was written partly by a neural network. In May, the book «Пытаясь проснуться» was published. It contains 24 short stories. Half of them were written by a modern writer, Pavel Pepperstein. It's a modern, popular, a little bit surrealistic writer. And half of them, namely 20 stories, were created by RuGPT, which took a pseudo Nero Pepperstein for this task. So half of these stories were written by neural network, fine-tuned in our SberDevices, and that's really great. And you know, it's really hard to guess who wrote which story, because you know, Pavel Pepperstein is sometimes so surrealistic that you say, oh, that couldn't be written by a real human, but then you understand that it was written by Pavel Pepperstein. And reading some text, you think, oh, the text is quite good, probably it's Pavel Pepperstein, but no, it's RuGPT-3. And yes, the books can write, neural networks can write books. And let us try to guess, by the way, who is who. Just try it. Where do you think the neural network is? Left or right? RuGPT. Where the right text is created by RuGPT or the left? Uliana, I'm terribly sorry. Please do not write 1 or 2. Because I do not understand how to count them. 1, 2, or 1, 2. From the left to the right, or from the up to down. Please write left or right. Yeah, you are absolutely right. Good students. But speaking about the like the both text, is quite hard to guess really, and usually some of my students, some of them think that the left was created by RuGPT, but it could be said that both of them can be written by a real human, and it's really quite interesting to read such books. For example, I read it and I really liked it. And as I myself do not know about the author, I do not know the authorship of each text. For me, it's quite difficult to guess sometimes who's who. Not only stories, but also poetry. In Sber, we now trained our AI poet, which writes quite a good poetry. In order to train such a model, we created a special training data set with the syllabus markup с разметкой ударений, so that the model was able to understand the rhythm of the poetry, and the result is quite impressive. I really liked some of these examples. So probably in the near future we will see some poems and many books written by neural networks. So that brings us to the end of our webinar. Today we basically spoke about the recent advances of NLP. They're really impressive. And believe me, if you begin to study this sphere and the sphere of data science in general, you will definitely like it, because it's really captivating when you understand how you can create and fine-tune such cool models which will solve so difficult tasks. And these tasks are so interesting. Sometimes when you train some model, it takes a lot of time, because you just start playing with it, thinking, oh, that's a really cool example. Oh, my model is cool. No, I need to do something. And that's really captivating, and that engages me to a great extent. And finishing the webinar, I would like to say that it is not that difficult. Today we looked just at the recent advances of natural language processing, and believe me, if you study this step by step, you will understand that it is not that difficult to understand all the inner things, and it is not difficult for example, after learning the standard NLP course, you will be able to create many of such good things. You will be able to fine-tune such language model. That's why I really like data science. It gives you the instruments and the understanding behind these instruments to be able to create so captivating things which really engage me, and I hope they will engage you. So if you are thinking about whether to apply for the Master of Data Science program or not, I would like to sum up that it is like a good opportunity to dive into all these interesting fields of data science, not only in NLP, but also in computer vision and many, many others. And here in the Master of Data Science program, we will learn how to implement all these cool things. Thank you for your attention. By the way, here is my Telegram channel where I write about most interesting and most captivating NLP news today. And now it's time to answer your questions. Pavel asks, which modern approaches in NLP do you teach on Master of Data Science program? Basically, we teach all the modern NLP approaches I've mentioned today. We start from the basics, like the concept of word embedding and language model. Then we switch to transformer model. We learn how to fine-tune language model, namely how to fine-tune BERT and other models, how to use GPT-3 model, how to use it without fine-tuning. And basically, you will learn how to pre-train a language model, how to fine-tune it, and how to apply it for your tasks, both classification and sequence, all three groups of tasks. How often code is too short? You said in 3 lines. Pavel, no, the code is not the 3 lines, but you can just download the model in 3 lines. You do not need to pre-train the model yourself. You may just load it from the site, like an escalar. KLF equals random forest. Here is the same, but here you need not 1 line, but 2 lines and the library import. And the code itself takes a few cells, if I could say so. Do you plan to add ethnic minorities languages? Zalim, we've already added ethnic minority languages to MGPT model. It knows the languages of Russian ethnic minorities. It already knows them, and that's really cool. Speaking about the philosophical question of Uliana and the tendency of total automatization and how many years human NLP experts will be needed, at this point we have we live in the era where NLP model, they just help like the real experts in the fields. For example, our writer, it is just a help for a real writer, but not a substitution. And to tell the truth, it's quite difficult to answer such philosophical question. It changes very, very fast, but I think that in general, we do not know how our brain works. That's why we could not really substitute real people. We can just imitate their activities. Speaking about the sources, can we get this presentation? Yeah, of course, you need just to push the files on the bottom right corner. Yes, you have files, bottom or top right corner, you have like чат, участники, files. Нажмите на кнопку файлы, и оттуда ее скачать можно. What kind of formal models are used in NLP? I've already mentioned the transformer. Mostly they are neural language models, the transformer models, such as GPT and BERT. Can we get, so speaking about the, I already have some questions in the, this is Uliana's question. And speaking about the resources, one second, I will send you the link to my favorite NLP course. Speaking about the links and the materials, I would really recommend this course by Lena Vojta. It is a good open source NLP course, which basically starts from the basics and explains all the NLP in all the details. And I really like it because it contains the reading materials, the tutorial, and the practical assignments. And there also exists a good NLP course from my colleagues, which they Sorry, I can't find. Валентина, не совсем вас поняла. Извините, я могу найти файл, чтобы скачать презентацию. Если вы можете его найти, ну, скачайте. Извините. Can't. Смотрите, правая верхняя часть экрана, справа будет такие вот, если вы туда наведете мышку, у вас вот туда вправо вверх наведите мышку, у вас выпадет участники, чат, вопросы, участники и файлы, и 3 точечки еще. Надо нажать на файлы, такая вот прямоугольничек. Нажмите на него, и вы увидите. Получилось, Валентина? How students of Master of Data Science program could train? A good question. There exists Google Colab. It's for training. The question is how, if I don't have Python on my computer, for example, I don't have Python on my computer, you may do everything in Google Colab. Google Colab is something like Google Docs or Google Slides, but for coding. So speaking about the presentation, I will try to, 1 second, I will then in case you have some difficulties with the presentation, I will just share a link from my Google Drive for this presentation. Here is the link for the presentation, and the first link is Google Colab. Basically, it is the platform where you can run all the code without, and you do not need to install anything on your computer. That's really great. So, if you do not have any other questions, thanks for coming. Duplicate question here. What question, Uliana? At this point, in order to add other languages, we need to basically repeat the procedure of MGPT training, and it is very cost consuming. It took several months on many hundred GPUs. That's why at this point, our goal is maybe to fine tune them better for the ethnic minorities or for the SNG languages. But at this point, we are not planning to add any other languages because for them, there also exists the problem of like data. We collected the data for those languages for which it can be quite understandable how to obtain a large training corpus of corpora for model training. So, thanks for coming today. Thank you for a very, very productive webinar. That was really great to spend this hour and 15 minutes with you, because really it was great, and I really liked that you were active. That's really great, and I hope to see you on our Master of Data Science program, where we can dive not only in NLP but also in computer vision, which is really a great sphere nowadays, and in many other data science parts. Thank you. Bye.